Good afternoon, I am Mr. Ish. Thank you for joining me. We're looking here at a sixth video on vector forms. We have multiple videos on this specific topic because it's that large and it's time well spent. Don't feel like you're seeing too many vector questions here and that it's a waste of your time. It isn't. All of this is very relevant. All of this you will likely see in pre-calculus. There are a few more things we have to talk about, but in this one we're talking about component vector forms, and these component vector forms are very useful in determining the resultant for more complex type of questions. You learn everything from basics, then you go towards hard. Here we're learning from simple, then we'll have to go into hard, but you have to learn this component vector form. You might have a clue on it, or you might actually know how to do it, but I'll present it anyway. You know R, or here to find the resultant, is equal to the sum of your two vectors. You can literally add them up. You'll do u1 plus v1 and you'll do u2 plus v2. Here you'll get your resultant minus 2 plus 2 is a 0, and here you'll do minus 1 plus 0 is a minus 1. But this right here is the easy way. You have to learn how to do this by the component vector form. To do that component vector form, you must break down this vector u and v into their magnitude and direction. You will have to determine the magnitude of u. You know it's going to be this square plus this square root. You'll have a root 5. And then you have to determine the angle. You know you'll do the y component divided by the x component, and you'll do inverse tangent. We can do 1 divided by 2 because the minus is cancelled out. Inverse tan, I get a 26.56. But this is a third quadrant angle. I'll add it to 180. I get an angle 206.6 degrees. So let's just write that, 206.6 degrees. This next one is easy. In terms of magnitude, you have this square plus this square root is just a 2. In terms of this angle, it's on the x-axis, so you know the angle here is going to be 0 degrees. Now you have to write them in their component form. The component form is the way you have the magnitude and the direction represented for each. For u, it's going to be root 5, and then you have cosine 206.6, and then you'll have sine 206.6 degrees. For the v vector, you're going to be doing the magnitude, and then you do cosine 0 and sine 0. Now how do you determine the resultant using this? You use like a long addition procedure. You'll add this row and you'll add this row, and you'll bring everything together into their two parts. Remember, we're doing all of this to determine our vector component. You'll do root 5 times this, and you'll add that to 2 times that. So let's do that. We'll do root 5 times 206.6 cosine. I get a minus 1.99. I'll add that to 2 times cosine of 0, which is a 2, plus 2. I get here a value very close to 0, and I might as well do that because I had a minus 1.99 and a plus 2, it's a 0. You can always round if needed. Now we'll do root 5 times the sine component plus 2 times that sine component. So let's do that. Root 5 times 206.6. Remember, I rounded this 0.6, so hence I'm going to have some decimal places to round, and I'll sign it. And now I'll add this minus 1 to 2 times sine of 0, which is 0, plus 0, I get a minus 1. And that's exactly what we're getting here in terms of our resultant. Our resultant components were 0, minus 1. Now this right here is not the magnitude of the resultant. This is just the components of the resultant, which is 0 and minus 1. To find the magnitude, you know now you do this square plus this square and root, and you'll get what? You'll get a 1. And then to find the angle, you're going to do this divided by this, and you'll do the inverse tan, but you can't do inverse tan of a minus 1 over 0. It's undefined. You're dividing something by 0. In this case, all you have to do is just very well graph that point, and you'll see when you graph this, it's on the y-axis on the bottom, and you'll know it's 270 degrees or 3 pi over 2. And this right here is your component vector form determined, where you break everything down into their components. This right here is the magnitude of each of your vectors, and this right here are the direction of each of your vectors, and you bring them down like that. If you want to write this exactly in this component form, you can. You know the magnitude of your resultant is a 1, and you know now you're looking at cosine 3 pi over 2, and you're looking at sine 3 pi over 2. This right here is your resultant in the format of a component form, which has a magnitude here and the direction right here. If you were to open this 1 times this and 1 times that, you'll get exactly 0, minus 1, and it's done. Our second question, we'll keep it short and quick. If your resultant is equal to minus 5, 3, we have to write it in component form. How do you do it? Well, you find the magnitude and you find the direction, and then we write it appropriately. The magnitude here is going to be minus 5 square plus 3 square all square root, and we'll bring the calculator. we'll do 25 plus 9. I get a square root of 34, and we can write here a square root of 34. Your direction here will be arctan of your second component divided by your first component, second and first, or y or x, and then you can do 3 divided by 5 minus inverse tan. I get a minus 30.96 degrees, or let's just say minus 31 degrees. But which quadrant are we in? Minus 5 comma 3 puts us in the second quadrant. So you take this minus 31 and you add it to 180, and you get a proper angle here of 149 degrees. So how do we write this in the component form? Your r vector is written in the component form as such: root 34, which is your magnitude, right? And then you draw this and you put your direction. You put cosine 149 and you put sine of 149. And if supposedly you were to open this up by multiplying this with that and that with that, you should get exactly here, relatively, because I rounded this up. If I didn't round it up, I'll get the exact, but let's do it. We'll do 149 cosine and we'll multiply by square root of 34. Root, I get a minus 4.99, which is minus 5. And then I do sine of 149 and I multiply that by square root of 34. I get a 3, which is good. So we're good. So remember, the component form is this. You have a magnitude right over here, and then you have the direction right here represented in this format. Thank you for watching. Have a nice day.